water, earth, fire, air. Long ago, the four nations lived together in harmony, but when the world needed him most, he vanished. 100 years passed.
Hey, I'm back.
I'm here to tell you right now, we don't care.
Let me tell you something.
We don't care.
So in today's video, I'm just going to talk about the binomial theorem. So let's go. Hello. Alright. Firstly, what is binomial theorem? Well, the binomial theorem tells us that a plus b to the n is equals to the sum of k equals 0 and n chooses k and a n minus k and then b to the power of k. From your probability class or perturbation class, you already know that n chooses k is just n factorial, k factorial, n minus k or factorial. If you don't know what a factorial is just how many ways you can rewrite the pattern, the sum of that, the product. So let's say 6 to the 6 factorial is equals to how many ways you can write the product of 6. Well, you can find this out by multiplying all the numbers that get to 6. So that, and then that would just be 2 times 3 is 6, 6 times 5 is 30, 30 times 4 is just 120. So there's 120 way of rearranging that thing. Rearranging the product for 6. So anyways, let's answer the next question. How does this work? To first answer the question, we need to know what binomial expression means. Expansion means. A bi is just 2. A nomial is 4. So a binomial expression is a form of 2. And to expand that, we're just expanding a form of 2. So like this, x plus y squared, and you want to expand that. Or a plus b squared, that's binomial expansion. So how do we expand this binomial expression right here? Well, first of all, we can use the method FOIL from your math class. And FOIL gives us a very good insight to this. FOIL is very useful. First, you can make that into that. And then you multiply a by b. So a by a plus b by a plus b by a again, b by a plus b by b, b by b, and that would equals to a squared plus 2ab, 2ba, I'm just gonna write it as ab, and b squared. Nice. So a plus b squared is equals to a squared plus 2ab plus b squared. But why? Why does FOIL works? Well, to first answer that question, we need to represent a plus b geometrically. So let's say that's a line of a plus line b. To square that line, we need to have a square. So now we have a, b, a, b, a, b. And that results to this. The area of a plus b times a plus b, which is a plus b squared, is equals to a squared plus ba plus ba plus b squared, which is a squared plus 2ba, which is 2ab plus b squared. Wow, we proved FOIL. FOIL works. FOIL is very useful. But how does FOIL work if we have something like this? A plus b to the power of 3. Well, let's first write it out as a more expanded form. So how do we use FOIL in this case? Do we just multiply that by that and then leaving the a? Or do we just multiply a by a and then a again? Or do we multiply a by a and then leave that? Let's think of it differently. So if we have a plus b to 0, we have 1. A plus b to 1 is a plus b. And a plus b squared is a squared plus 2ab plus b squared. Now a plus b cubed is just 2, a plus b to the power of 2 times a plus b to the power of 1. So therefore a squared 2ab plus b squared times a plus b. So we get a plus b cubed equals 2 a times a squared, a times 2ab, a times b squared, plus b times a squared, b times 2ab, b times b squared. So let's do that. A times a squared is a cubed. A times that is a squared b. That's ab squared. Now b is a squared b. And then that's 2ab squared. And then that's just b cubed. Nice! So, to first answer this question, we need to simplify those two. And then those two. Alright, so a cubed plus that is 3a squared b plus 3ab squared plus b cubed. The coefficient is 1, 3, 3, 1. So, let's count this coefficient again. When you have a plus b to the power of 1, the coefficient is 1, 1. When we have a plus b to the power of 0, the coefficient is just 1. Now we only have a plus b squared is 1, 2, 1. And you have a plus b cubed, you have 1, 3, 3, 1. How does that work? What is the pattern here? What are you trying to say, Vectorzoid? Well, I'm trying to relate this to the Pascal triangle. And you probably know about Pascal's triangle in probability class. A Pascal triangle just showed the distribution of things coming down. If you have a bunch of balls, a bunch of, coins or something, whatever, and let's just say that this has, a bunch of places going down, like that, and like that. I don't know how to draw stuff, but like that or something like that. Yeah, oh my god, this looks disgusting. But the Pascal's triangle shows us that when ball comes down, most of them will be here, and then less over here, and then less over here, and then even less over here, and then they're probably just 0 over here. So it shows the probability of balls being here, 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 infinitely. So let me draw the Pascal's triangle. So the Pascal's triangle shows that 1, if a ball comes down, there's 100% chance that it's gonna go this path. And then once it takes this path, it either takes this path or this path. If it takes this path, then this will lead to here or here. If it takes this path, that will lead to here or here. So there's two paths of leading you to here, but there's only one path of leading you to here. So therefore, you can already see that the probability of ball landing over here is more than over here in here. So let's do this more. There's one path over here, one path over here. There's 1 plus 2 paths, and 1 plus 2 paths over here. Let's do some more. There's 1, 4, 4, and 6 paths over here. Wait a minute. Did you see that? The patterns? That's number 1. That's 1 and 1. That's 1, 2, 1. And that's 1, 3, 3, and 1. Remember this? Right here? Yes, that's right. So when a plus b to the power of 1, you have leading coefficient of 1 and 1. A plus b to the power of 0, you have 1. A plus b to the power of 2, you have 1, 2, 1. A plus b to the power of 3, you have 1, 3, 3, 1. Just like that. So now we can say that this part is going to be a plus b to the power of 4. Right? And based on the binomial theorem, it shows us that a plus b to the power of 4 is going to be equals to k equals 0, which is that, and then 4 until it goes to 4, and then that is going to be just 4k, and then that is going to be just a 4 minus k b k, and then 4 chooses k is going to be 4 factorial k factorial 4 minus k factorial, the sum of that. And once we do the math, we'll also get a plus b 4 equals to 1, 4, 6, 4, and then 1 right here. So what is the the variables that we put here? We know that, we know the leading coefficients, but we don't know the variables. And let me tell you, the variables is very easy to find out. The variables from this pattern right here, it's just A1 and then A2, 1, A0, A0. And then here is A cubed, A squared, A1, A0. The same thing goes with B. B2, B1, B0. B cubed, B2, B1, B0. So we can do that. We can just say 1, A4, I'm just going to write that here. A3, A2, A1, A0. So we don't have to write that. Now B4, B3, B2, B1, and B0. We don't have to write that. And rewrite that, we will get A4 cubed plus 6A squared. B here. B2 plus 4AB cubed plus B cubed. And that's right. That equals to, that is going to be equals to, let me write this down. That's going to be equals to the sum, k equals 0 until 4. 4 chooses k, A4 minus k, B, k.